Hey, wonderful viewers, welcome to a quick note. Today we're diving into a fascinating topic. What is the greenhouse effect and is it inherently bad? Get ready for a quick and insightful exploration. So, what is the greenhouse effect? Is it inherently bad? You might have heard about the greenhouse effect when people talk about global warming and all the problems it's causing, like melting glaciers and crazy weather changes. But guess what? The greenhouse effect isn't all bad. In fact, it's super important for keeping our planet cozy enough for life to thrive. Think of it like Earth's warm hug. Without the greenhouse effect, our home would be as chilly as Mars. And that's not a fun place to live. So what's this greenhouse effect all about? Let's find out. Let's break down the basics of the greenhouse effect. The name comes from greenhouses that create a warm environment for growing plants. This same process is what keeps our planet cozy enough to support life. An everyday example of the greenhouse effect is like what happens in a car left out in the sun. Think about it. When your car sits in the sun for a bit, you've probably noticed it gets way hotter inside than the temperature outside. Here's why. The sun's rays come in through the car's windows, and some of that heat gets absorbed by the seats, dashboard, carpeting, and floor mats. It's like a little heat trap inside, showing us a mini version of the greenhouse effect at work. Let's dive into the next part. When those objects in your car release the absorbed heat, not all of it escapes through the windows. Some of it bounces back in. Here's the deal. The heat given off by your car's seats is a different type of energy than the sunlight that initially came through the windows. The glass of the windows doesn't allow as much of this specific energy to pass through. So you have energy coming in, but not all of it can leave. The end results? The temperature inside your car gradually goes up. Now think of Earth's atmosphere as one massive spherical car window. Earth's greenhouse effect is like a giant version of your car scenario, keeping our planet much warmer than the chilly vastness of outer space. Cool, huh? Let's explore the natural greenhouse effect on Earth. When the sun shines on Earth, a significant portion of its warmth is absorbed by the land, oceans, and plants. About 30% of this sunlight reflects back into space due to clouds and reflective surfaces. Interestingly, even the absorbed warmth doesn't stay put. It's released, akin to how a car's seats release heat. This exchange sustains Earth's balance, warming up from the sun and cooling down by releasing warmth. With more sunlight, Earth emits more heat. Some of this heat escapes into space, while some reflects back to Earth. When it encounters gases like carbon dioxide and water vapor in the air, it reflects back down, a crucial part of Earth's natural greenhouse effect. This delicate dance maintains our planet's habitability. Apologies for the oversight. Let's keep it without numbers. The lingering heat in our atmosphere is crucial, keeping Earth warmer than outer space's cold emptiness. More energy entering through the atmosphere than leaving creates the cozy greenhouse effect we rely on. Without this warming system, Earth could be as chilly as Mars, lacking a thick enough atmosphere. Mars struggles with extreme cold as it can't bounce much heat back to its surface. The greenhouse effect acts like a built-in essential blanket for Earth's comfort. However, maintaining a delicate balance is key, as too much heat trapped in our atmosphere can lead to problems. The Industrial Revolution marked a shift, with human activities upsetting this equilibrium. Environmental concerns arise as excess heat in the atmosphere causes imbalances. While the greenhouse effect is necessary, it requires careful management for a healthy planet. Striking this balance becomes crucial in navigating Earth's climate challenges. Let's explore the idea of greenhousing Mars. Some scientists believe we can change Mars by a process called terraforming. They want to send factories there that release water vapor, carbon dioxide, and other gases into the Martian air. The goal is to make the atmosphere thicker, trapping more heat and creating a place where plants can grow. Once plants spread across Mars, they'd produce oxygen. In a few hundred or 1,000 years, we might have an environment where people can walk around, all because of the greenhouse effect. It's like using science to give Mars a new look, borrowing some warmth from Earth. Let's delve into the impact of fossil fuel combustion on the enhanced greenhouse effect. The greenhouse effect, usually keeping Earth cozy, can go haywire from too much human-made carbon dioxide. Think of it like a seesaw tipping too much to one side. Scientists say without our atmosphere, Earth's temperature would drop by about 54 degrees Fahrenheit. That's as cold as Mars, chilling around minus 9.4 degrees Fahrenheit. Our atmosphere and its natural greenhouse effect act like climate guardians, stopping us from freezing. But if we pump loads of heat-absorbing gases, thanks fossil fuels, it's like cranking up the heat too much. This excess traps radiation, heating our planet too much. Imagine having too much of a good thing. In simple terms, Earth's struggling to cool down, leading to what we call global warming. The main troublemaker? More carbon dioxide in the air, the second most common greenhouse gas after water vapor. Plants usually help keep CO2 in balance, but humans burning lots of fossil fuels mess that up. Too much CO2 too fast messes with how our planet handles temperature, causing global warming. We're making more CO2 than plants can handle, especially with deforestation. Before the Industrial Revolution, we had 280 parts per million of CO2. In the mid-1900s, it went up to 300 ppm, reaching 420 ppm in 2023. This spike made Earth's temperature rise by 2 degrees Fahrenheit. Hitting a 2 degrees Celsius increase could lead to big problems, like melting ice, floods, strange weather, and hurting wildlife homes. To fix this, we're trying with agreements like Kyoto and Paris to cut down on CO2. The big question is if these efforts will be enough or if we're close to a point of no return. We'll find out with time. That wraps up our quick exploration of the greenhouse effect. If you found this episode enlightening, don't forget to show some love. Give us a like, hit subscribe, and turn on those notifications. For more quick insights, stay tuned to A Quick Note. Catch you in the next one.